Hi, welcome to the lab. I would like to sketch out a API for a scanner generator library in this video. So maybe a couple of words this. So I plan to do a couple of small little projects that all require some sort of parsing. And to make your life easier, parsing is done in two separate steps. First, so let's start a step earlier. So the source file stored on disk, and a file consists of multiple characters. And to make your life easier when parsing this file, you first group together your characters into meaningful chunks, which are basically almost always called tokens, which are basically the smallest unit of information that is that has meaning for your language. And of course, every scanner, you can always write your scanner by hand, and this is also the fastest approach. So I mean runtime performance, but because you can then fine-tune every little screw and make every little cog turn fast. But I would like a library which lets me very easily define a scanner. It is not quite as fast, but it is just for development of my language. And always, I can of course always throw away my scanner and write a scanner by hand if I choose to do so. But for language development, it is quite convenient if you just add new tokens into a specification, regenerate your scanner on demand, or maybe don't generate your scanner. So I mean, don't generate a source file which you then compile, but maybe you can just generate a transition table or so, something like this, and simulate your scanner in memory. So let's not get too much carried away. Let's not get too much into detail, but let's just start by sketching out a simple API. So I set up here a very basic project. I can just hit run and it builds, runs, prints hello world. Basically, I'm finished, ship it. So, as I already said, I would like to have a scanner specification where I could add tokens to. So, basically, I took inspiration from Flex, which I already prepared, where you can add tokens for your symbols or for your keywords. And basically, if this keyword, if your source file contains this keyword, in this case, flex will return this symbol. And also it supports regular expressions, which are defined here and are used here. For example, for, I think those are, identifiers. Yeah. So basically, you can do it like this. So you could do it like this, but yeah, so you have a way to specify your tokens which are relevant for your scanner. And I would like to do a similar thing, but as a library, as I already said, so no file format yet. Maybe later, much later, but first of all, the library. So let's start. I would like a class which is called specification. Specification, yeah, like this. And this class should have a way to add tokens. I already said. So let's say a literal token. So literal token, I'm calling those which are either keywords or symbols, so keywords or symbols, which are matched literally in the source file. So that's what I'm calling literal tokens. But well, this is a literal, not the best name, but symbol token, keyword token. But well, already I'm not sure how to name things. Great. So literal token. So I would like a common name for symbols and keywords, which are, well, let's just keep literal token. I can always rename it. So, and then I would like to accept a name and basically a name and the token itself. So, but I don't want to work with const char stars. So let's just introduce a class called stringView, which for now just gets a constructor which does nothing for now. To schedule the API, of course. Everything will be implemented much later. So, and then I can accept a string view here and a string view here. Oh, string view. And I also would like to add a regex token, which is basically a way to give a regex. So let's just stub it out. So then I could create an instance of my class and add, for example, a literal token. Let's do plus. So first the name plus, and then the token. So the symbol plus. And let's also do multiply. But I'm calling my tokens not as their semantic meaning, but the name of the symbol itself. So this is called plus, and this is a star, but the semantic multiply is attached in programmers' heads, basically. So, but I'm calling it here how the symbol is called. And let's keep it simple and just add a regex token, which is called literal. And I'm just using a number literal here, so an integer literal. Integer literal given as a regex consists of a digit, so 0 to 9, and basically we have to have at least one character to be a literal, or it can be repeated how often you like. So this accepts, for example, a 5 as a literal, but also a 42, since, well, you first choose the 4, then you can have, this pattern repeats how often you like. You could also have 420, you could also have, I don't know, 1337. So basically, and if this is our language, of course, we would like to eventually write something like, I don't know, maybe something like this. And so, of course, we would also define white space. White space in this language would be space, carriage return, line feed, carriage return. Yeah, maybe that's it. So then let's keep it as a very, 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 very easy example. So then, I have a specification. I can print it out. I could maybe serialize it, and maybe I could read a specification from a file, but currently I don't care. I will just hack it to the computer for now. So, and then I would like to take the specification and compile it to a concrete scanner, which I can use to well, I don't really have decided what I would like to do, but to some value that I can use to, for example, simulate my scanner, or which I can use to generate a real scanner as a program, or to do something else. But let's for now call this grammar, I suppose. I would like to compile my specification into a grammar. Just stop it out. I would like to have a public API which returns a grammar object. Compile, and it gives me it accepts a specification and returns a grammar. But of course, yeah, okay, this method can fail. So, for example, you could give an invalid regex here. Maybe you forget a missing bracket here. Then this regex will be invalid, and then this method has to communicate an error somehow. And I dislike exceptions. I won't use them at all. So I would like to communicate the error back to the user, for example, through a separate error type. So let's just sketch it out for now. Grammar. Let's just call it compile error. And this is no exception, but just it encodes the error, and the user can use this class to print it or show it to the user, because since it is a library, well, this just describes the error, and you can do whatever you want with this value. So, for example, so this method either returns a grammar or a compile error, and so the functional programming world, there is literally a class called either, which does this distinction between an error, a expected result, and I'm just going to shamelessly steal this concept. So it's a class called either, which either does the name holds a value of type L or a value of type R. So not special, but I will not implement it here. Also, not yet. We'll just use this to stub it out. So, oh, I'm so sorry. So then this method can return a compile error or a grammar, depending on success or failure case. And then I can, of course, it in grammar, and I then can evaluate grammar and check if it returned an error or not. So, but let's just keep it very simple for now. Let's just keep it like this. So basically, this is our plan for now. So let's think of what we actually need to implement. So I need a string view class. So let's just keep nodes, make some nodes. I need a string view. Then I have to remember which tokens I added. So I need a list, I think, just for the API. Then I need to implement either. So, and this, of course, is the implementation of the library itself, but I'm just thinking of which helper things I need. So, and then I have to think about how I would like to do logging, since I just love to hate the C++ standard way of printing. So let's not talk about it. It doesn't exist. So I mean the streams, of course, the shift operators, I hate it. So I'm not going to use it. So, logging, printing. So something like this. So I think that is a good plan, I suppose. Currently thinking. So this is the things I need very early on. So let's just work those first, I suppose. And of course, I think we need a lot more data types, but let's just, this is our first our first analysis of what we actually need. So yeah, I will start working on those. So yeah, I'm not quite sure in which order I will do them, especially since lists have to allocate memory. Another thing. So string views don't allocate memory, and you can go from each string to a string view since it only is an immutable view of a string. So that's the name, basically. But lists have basically I want them to have a add or append method. I don't know how to call it yet, but they have to allocate memory. So let's talk about memory. So maybe I have to do this first. So maybe either first and then allocation. And maybe logging would be good if we can do this first. But also it would be very easy to just print it into a temporary string. So I think so. Maybe I have to do logging first. So I'm not really sure in which order I will do this. I will make a plan, and yeah, I think I will see you soon. I hope to see you. So thanks a lot for watching. Have a great day.